All right, I do want to keep rolling with 1.3 today, though. We've got the rest of class today, and then we've got class time tomorrow to do 1.3. Our focus today is mainly going to be on adding, subtracting, and multiplying. We did an adding example yesterday. We did a subtracting example yesterday. I will say, while adding and subtracting aren't necessarily fundamentally difficult, watch your signs. Make sure you're only combining things that are like terms, and watch your signs, because those are the common mistake places where I still make little mistakes if I'm going too fast or not paying attention. All right, so let's multiply some binomials. Down here on part C, I'm going to need to use double distribution, and I'm going to need to combine my like terms together. So I'm going to draw my little arrows so I can do that appropriately. I've got 3 times 2x, which will give me 6x. 3 times 5, which will give me a positive 15. Negative x times 2x, so minus 2x squared. Negative x times 5, so minus 5x. I see a couple things I can combine together. What can I combine? 6x and negative 5x. And as I write my answer in its final form, it is understood that for polynomials to be fully simplified, we're going to write those in decreasing order, so highest power at the front. So I'm going to have negative 2x squared plus x plus 15 as my final answer here. So far, so good? All right. Squaring a binomial, we have practiced this a couple times. I'm going to write our pattern off to the side. A plus or minus b, if I'm going to take that polynomial and square it. How will the expanded binomial come out to look?
A squared plus or minus 2ab plus b squared.
Plus b squared. Absolutely. All right, so let's go through that pattern on part D. So I'm going to take my first value and square it, my first term, and that's going to give me what? 9x squared. I'm going to multiply my two terms together, 21x, and then we double it. 42x, positive 42x. And my last term, 49. Notice when I get done squaring that binomial, even though inside the parentheses both terms were negative, my result when I expanded it was what? Every single term was positive, which means that this is exactly the same as 3x plus 7 squared, because I get the exact same result when I expand that, when I actually simplify it out. All right, let's do a couple more. We're going to do E together, and then I want you guys to do F and G on your own after that. I'll give you a couple minutes to do that. E is beastly, but not necessarily difficult. Instead of doing double distribution, I'm going to need to do triple distribution, because I've got 3 terms in each of these factors. So I'm going to take my first term and distribute it. That's going to give me 2x to the 4th minus 2x cubed plus 8x squared. Then I'm going to take the 3x and distribute that to each piece. So I'm going to have a positive 3x cubed minus 3x squared plus 12x. We're going to end up with 9 terms here. And last but not least, we're going to distribute this negative 5 to each piece. So minus 5x squared plus 5x minus 20. So far, so good? Okay. And now we got to look for all the like terms that we can combine. I know from the way these two factors were set up that my first term and my last term will not have anything to combine with. I'm not going to have any other x to the fourths, and I'm not going to have any other constants. So I've got 2x to the fourth. How many cubed terms do we have? 2. We've got a cubed term here and a cubed term here. When I combine those, I get just a single x cubed, and it is positive. How many squared terms do we have? 3 squared terms. Got one here, 8, -3, and -5. What happens? They all cancel out. So these just drop out of my polynomial. How many linear terms do I have? Things to the first power. 2. 12 and 5. Combine those to get 17x. And then my last term is -20. It does not have anything to combine with. So far, so good? Okay. I want you guys to do F and G. I'm going to give us about between 3 and 4 minutes to do those two, and then we'll go through them. Right. What did we get for F? 9x squared minus 24x plus 16. Beautiful. For G, you have to do this in 2 steps because you have to follow order of operations. Which piece do we have to focus on first? Yes, x minus 1 squared we have to do first, and then we will take that result and triple distribute it to that last factor. So we're going to get x squared minus 2x plus 1 from squaring our binomial, and I need to multiply that by x plus 4. So I'm going to have x cubed plus 4x squared. I'm going to have minus 2x squared minus 8x plus x plus 4. And then we're going to combine our like terms together to finish this. What are the like terms that we're going to need to combine? X squareds and our linears here, the just x's. So I'm going to have x cubed plus 2x squared minus 7x plus 4. So far, so good? For those of you that struggled a little bit with that last one, does it make sense now? Okay. Let's do a couple more. Today is mostly, like I said, focusing on adding, subtracting, and multiplying. What all do we have going on with H? Multiplication and addition, yes. So we're going to multiply these two together. We're going to multiply these two together. And then thankfully, we do not have to triple distribute anything. We will just add those results. So I'm going to go ahead and drop my addition sign here. I'm going to have 2a squared minus 8a. And then over here, I have 2a squared minus a plus 6a minus 3. Now we combine our like things together. I have some 2a squareds to put together, so I have 4a squared. I have negative 8a, negative a, and a positive 6a, which will combine to give me what? Negative 3a, so minus 3a, minus 3. I looks really disgusting, doesn't it? Fractional exponents. As we are multiplying, what are we going to be doing with our exponents? Adding our exponents. Okay, so let's go through and do this. A to the 1/3 times a to the 2/3. A to the 3/3, which is just a. So I'm going to go ahead and write down a to the 3/3 just so we're really clear on where everything comes from, because I know I'm going to need to combine my like things together here in a minute. All right, then I do a to the 1/3 times my middle term. So I'm going to have positive a to what power? 2/3. And b just stays 1/3. So far, so good? All right. Distribute to my last term here. I cannot add those exponents because the bases aren't the same. So I'm going to have plus a to the 1/3, b to the 2/3. We doing okay so far? All right. I'm going to take this minus b to the 1/3 and distribute that to each piece. So I have minus a to the 2/3, b to the 1/3. Remember, when we're writing these, we want to write them in alphabetical order. So that's why I put my a at the front there. And then I'm going to have minus a to the 1/3, b to the 2/3, minus what? B to the 3/3. I know this guy right here is just a, correct? When you look at those four middle terms, the light blue and dark blue in the middle, is there anything interesting that you see? They're all AB. Look closely at the ones that will be like terms because they have the same powers. They're opposite signs. So what's going to happen to those pieces? They're going to cancel out. These two are going to cancel, and these two are going to cancel. Yeah, I have a minus b. Looked really gross, cleaned up very nicely. Got 3 more problems. We'll see if we can get through them all. Or at least that's as far as I wanted to get for today. That was kind of like my mental stopping place for today. All right. We're going to cube a binomial. So let's start there. If I want to cube this binomial, what's the best way for me to start this? Square the first, like square it, and then triple distribute. Yes. All right, so I'm going to split this up to be 2x minus 5 squared times 2x minus 5. So far, so good? Okay. 2x minus 5 squared will give me what? Yep, careful there. It's 4x squared, because remember, I take the 2x and I square it. So I have to square the 2 as well as the x. Minus what? 20x. And then what? Plus 25. We're going to take that and triple distribute to 2x minus 5. So I'm going to have 8x cubed minus 20x squared minus 40x squared plus 100x plus 50x minus 125. And then we'll combine our like pieces together. And thankfully, they are grouped pretty nicely for us. We've got our squareds side by side, and we have our linears side by side. So what am I going to have when I get this all combined together? 8x cubed minus 60x squared plus 150x minus 125. Yes. Just like when we square a binomial, there is a pattern for cubing a binomial as well, so you don't have to square and then distribute. Go ahead and jot this down on your page. If I want to take my binomial and cube it, my pattern for that, my first term is going to be cubed. Notice we did that. 2x cubed. I have 8x cubed. And then it's going to be plus or minus 3a squared b. Notice when I take the a squared and I multiply it to b, so 4 times 5, that gives me 20, and then I triple it. Plus or minus 3ab squared plus or minus b cubed. This is a nice to know, but not a need to know. I would say squaring a binomial is an absolute need to know. Cubing a binomial is a nice to know. So I wouldn't spend a lot of time working on memorizing this necessarily. What do you notice about the two pairs down for K? They're exactly the same except for signs. These are called conjugate pairs. With conjugate pairs, when I multiply those together, that middle term is going to drop out. So it's going to be the first term squared minus the second term squared. It's going to come out to be a difference of perfect squares. So this is going to be what? X minus y. Anytime we have conjugate pairs, square the first one, square the last one, subtract in between. All right, I think I have just enough time for you guys to do L, and then I'll pop my answer up. We had conjugate pairs down there as well. So square the first one, 3a squared, whole thing squared, gives me 9a to the 4th. Take my last term and square it, so that makes it b, and subtraction in between. You guys feeling reasonably okay about this? Okay. The 1.3 homework is due on Thursday. Tomorrow, our in-class focus is going to be on factoring. We are going to factor, 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 with a little more factoring, and then at the end, just as a special treat, we're going to factor some more.